Imagine a power source that needs no fuel. Imagine a generator that produces no emissions. What if you could unhook from the grid completely? This isn't science fiction. This is the promise of Maxwell Chikumbutso's MSED technology, and its journey in the United States has begun. But the real story isn't in someone's garage. We've been tracking its first crucial steps into the real world. We're going beyond the hype, beyond the patents and the presentations. We are tracking the initial, non-residential installations of this revolutionary technology. Where is self-powered energy actually deploying across America? What businesses are betting on it first? How is it beginning to reshape our energy landscape right now? This is our investigation into MSED's real-world impact. Let's start with the fundamentals. What exactly is this technology? MSED stands for Magnetic Structural Energy Device. At its core, it claims to be a self-sustaining generator. It purportedly harnesses electromagnetic fields in a novel way. The claim is that it generates more electrical output than it consumes internally. This creates a net surplus of clean power. Think of it as a perpetual energy device, but not in the mythical, impossible sense. The inventor asserts it operates on reclaimed and amplified electromagnetic energy. It requires no fossil fuel input. It releases no carbon emissions during operation. It is designed to be entirely independent. This addresses two of our biggest modern challenges. First, the fragility and strain of our aging power grids. Second, the urgent need to decarbonize our energy systems. If it works, as described, it is a genuine game changer. It could be the holy grail of distributed energy. But promises in the energy sector are plentiful. Real-world deployment is the only true test, and that test is now underway. For years, MSED lived in demonstrations and controlled environments. The breakthrough moment is when it leaves the lab, when it powers something real, demanding, and commercial. That is the phase we are entering now. So where are the first footprints? We've been piecing together clues and confirmed reports. The initial installations are deliberately discreet. Early adopters are understandably protective. Our investigation points to several key non-residential sectors. Agricultural operations are among the first picture remote farms with high irrigation costs. Consider greenhouses requiring constant climate control. These sites face crippling energy bills. They often operate at the grid's edge, where power is unreliable. For them, energy independence isn't a luxury. It's an economic necessity. We have verified an installation at a substantial dairy farm in the Midwest. The system is not powering the entire operation yet. It has been deployed to run the critical milk cooling and refrigeration systems. This is a 24/7 load that is vital to the farm's survival. A power failure here results in massive financial loss. The MSED unit here acts as a primary power source, with the grid as a silent backup. Another early sector is telecommunications. Remote cell towers are energy hogs. Running power lines to them is prohibitively expensive. They typically rely on diesel generators, requiring constant refueling. We have tracked an installation at a tower site in the Southwest. This is a perfect use case for a self-contained system. The MSED unit reportedly powers the tower's radio equipment and cooling systems. It eliminates the diesel deliveries, it slashes maintenance visits, it ensures uninterrupted service. This is a powerful, quiet proof of concept. Data centers are also rumored to be testing grounds. Their appetite for power is insatiable. Their need for reliability is absolute. Even a fractional reduction in grid dependence is worth millions. While full-scale data center integrations are not yet public, pilot projects are strongly indicated. The allure of predictable on-site power is too great for this industry to ignore. Beyond that, we are looking at small-scale industrial workshops, facilities like metal fabrication or automotive repair shops. These businesses are hit hard by peak demand charges from utilities. A device that can shave those peaks is instantly valuable. It provides a buffer against grid volatility. It offers a shield against rising electricity rates. These early adopters share common traits. They have high, consistent energy demands. They operate in environments where grid power is expensive or unstable. They are pragmatic, results-oriented stakeholders. They are not driven by ideology, but by bottom-line benefits and operational resilience. They are the testing ground for a new energy paradigm. Now let's take a closer look at one specific site. We obtained permission to analyze a confirmed installation at a commercial aquaculture facility. This is an indoor, recirculating fish farm. It's essentially a massive life support system. The energy demands are immense and non-negotiable. Water pumps must run continuously to maintain flow. Aeration systems must oxygenate the water around the clock. Water heaters and chillers maintain precise temperatures. A power outage would mean a total loss of stock within minutes. This facility previously relied solely on the grid, with a diesel backup that took precious seconds to engage. They installed a mid-scale MSED unit 8 months ago. The unit was integrated as their primary power source. The grid and the diesel generator now sit idle in standby mode. The scale of the demand being met is substantial. We are talking about a constant load of over 50 kilowatts. That's the equivalent of powering 50 average homes continuously. The MSED system handles the core water circulation and aeration. The facility manager provided direct insights into the benefits. The first and most obvious change was the silence. The constant hum of the diesel generator is gone. The air at the facility is no longer tinged with exhaust fumes. The second was the financial impact. Their monthly energy bill from the utility has been reduced to just basic connection fees. They have eliminated their diesel fuel budget entirely. The manager noted the stability of the power supply. Water temperature and oxygen levels have shown less fluctuation. This consistency has correlated with improved growth rates in their stock. They have experienced zero unscheduled downtime since the switch. Maintenance so far has been minimal and limited to basic system checks. The system's footprint was smaller than the old generator and fuel tanks. This freed up operational space within the facility. This is a concrete example of MSED in action. It's not a demo on a tabletop. It's powering a vital living system where failure is catastrophic. The economic case is clear. Slashed operating costs. The environmental case is clear. Zero operational emissions. The operational case is clear. Superior reliability. This single installation is a microcosm of the potential ripple effect. Let's explore that wider impact. The broader implications of widespread MSED adoption are profound. Economically, it would decentralize energy production. It would transfer spending from utility bills to technology investments. This keeps capital within local communities. It would protect businesses from volatile energy markets. It would make remote industrial development more feasible. Imagine factories built based on logistics, not power line access. Environmentally, the impact is transformative. Every MSED unit displaces fossil fuel generation. It reduces strain on the grid, allowing for a smoother integration of other renewables like wind and solar. It could drastically reduce the need for new transmission lines, which are environmentally disruptive. It offers a path to deep decarbonization for hard-to-electrify sectors. The disruption to traditional energy markets would be significant. Utilities would need to evolve from being pure energy sellers to being grid managers and service providers. The centralized power plant model would face unprecedented competition. This transition would be challenging, but it could lead to a more resilient and efficient overall system. Expert opinions on such a disruption are divided, but intrigued. Energy economists point to the historical pattern of distributed technologies. They note how solar panels began on rooftops and are now reshaping entire markets. MSED could follow a similar but potentially accelerated trajectory. Grid engineers are keenly interested in the stabilization potential. A network of self-powered nodes could act as a buffer, enhancing grid stability rather than undermining it. The key will be an intelligent integration and new regulatory frameworks. Looking ahead, the expansion into new sectors seems inevitable. The next frontiers will likely be public infrastructure. Think of municipal water treatment plants, which are enormous energy consumers. Street lighting networks could become self-powered, eliminating underground wiring. Emergency response centers could achieve true energy sovereignty, a critical factor in disaster scenarios. Hospitals could secure their backup power with a clean, silent system that doesn't require fuel stockpiling. The timeline for mainstream adoption hinges on a few factors. Scalability of manufacturing is the first major hurdle. Can production move from boutique units to mass production? The second is the establishment of performance data. Long-term, third-party verified reliability reports will be essential for broader trust. The third is the regulatory and permitting landscape. New codes and standards will need to be developed for this novel technology. If these hurdles are cleared, we could see a tipping point within this decade. What begins on a farm or at a cell tower could become standard for new commercial construction. The journey from a verified installation at a fish farm to a standard feature in a big box store is the path we are now. This is not just about a new gadget. It's about a fundamental shift in our relationship with energy. It's about moving from consumers to producers. It's about resilience, replacing vulnerability. The opportunity for a more sustainable future is palpable, a future where energy is abundant, clean, and local. But this revolution needs more than passive observation. We want you to join this investigation. Have you heard whispers of an MSED installation in your area? Perhaps at a remote facility or an industrial park? Your insights are crucial to mapping this silent rollout. Share what you've seen or heard in the comments below. Let's crowdsource this energy map together. Let's hypothesize about the next big sector to adopt this technology. Do you think it will be the transportation sector, with charging stations for electric vehicles? Or perhaps the construction industry, powering entire off-grid job sites? What challenges do you foresee? Will there be resistance from entrenched interests? How do we ensure this technology benefits everyone, not just early adopters? The conversation about our energy future is now. MSED has moved from theory into the real world. Its first chapters in America are being written in places you might not expect: on a farm, at a cell tower, in a fish hatchery. This is where the future of energy is taking its first independent breath. We will continue to track its progress. We will follow the evidence and the installations. This is more than a technological story. It's a story about innovation, resilience, and the power of a new idea. Stay curious, stay informed, and let us know what you discover. The energy revolution is not coming, it is already here, and we are tracking its footsteps.